Hi, this is Mr. McConley, and this is BKW Physics. I want to address two words that sound similar, but definitely don't mean the same thing in physics. Equilibrium and equilibrant. Now, first of all, you got to back up a little bit to net forces to think about equilibrium. If you go skydiving someday and you jump out of a plane, you will be falling quickly towards the earth, maybe like that, there you are falling. And you will fall faster and faster until you reach what's called terminal velocity. And at that point, the force that's pulling you down, gravity, and the force that's fighting against that, we'll call it wind resistance or something like that, these two will be equal. So your net force will be equal to what number? 0, correct. When your net force is 0, you don't speed up anymore. Okay? So you have an acceleration of 0. So when your net force is 0, you have an acceleration of 0. And what we say is, in this situation, you are in equilibrium. Because the forces are all kind of balanced, we're in equilibrium. Now, I want to make a quick note. You can be at rest, in other words, not moving and be in equilibrium. You also can be moving at a constant speed. That idea keeps popping up a lot in Regents' questions, so I want to just make sure you understand that. When you're in equilibrium, you don't have to be moving at a constant speed, you don't have to be at rest, you just have to be in one of the two situations. Now, switching gears to equilibrant, this might go something like this. Say you have vector A pointing this way, and you're going to add vector B like that. We've been doing these sort of problems. Well, when you do that, notice they are connected tip to tail, proper connection. You will get a resultant that is from where you started to where you ended up. That might look something like this. Well, that's all information you already knew. So what's an equilibrant? Well, an equilibrant is one vector that would cancel out your two original vectors. It's one vector that would cancel out your two original vectors. So, we got the resultant, and the resultant is the combination of these two. So what do you think the equilibrant is going to look like if it's one vector that would cancel out your original two? It would look just like the resultant. It would be the same length, I agree, but it would be... You're going to add something to that, Joe? That's all right. Come back to you. It's going to be the same length as the resultant, but it's going to be exactly in the opposite direction. So the equilibrant is going to start here. Does that look the same length? Ish. Right there, I have drawn an equilibrant. It's one force that will cancel out the resultant, or cancel out the two vectors that you originally added. And the equilibrant would make this situation in equilibrium. Because once you have the equilibrant, it's going to cancel everything out. You're going to have a net force of 0, so you're in equilibrium. See how the two are tied together?